hydrogen fuel cells and things like that. There's a protein called hydrogenase that uses metals to do chemistry with hydrogen. You can do radical-based chemistry. You can do a lot of really great things when you have a protein that has a metal in it. So let me introduce you to some of the concepts and terminology involved in this. So we're going to have a metal, and the metal is going to be bound to stuff. So one of the great features of transition metals is their ability to form complexes with small molecules or ions. This applies to a protein system in the case that instead of small molecules, you have amino acids of proteins. It can also form complexes with. So the way that they do this is metals have often, they can attract electron density, usually a lone pair of electrons from another atom. And so they can form what are called these coordination complexes. So now we're going to review for a minute. You have donor atoms. They're called ligands. And we can think about something that we learned when we talked about acids and bases, our more broad definition. So donor atoms are ligands, and ligands are what? Lewis acids or Lewis bases, and what do they do? Okay, let's just take 10 more seconds. So most people thought donor atoms, that the answers that had donate electrons did better. So that was good reading of the question. But they are Lewis bases. So Lewis bases donate electron pairs. So here are some examples that you will see of ligands that we'll be talking about in this unit. You will become very familiar with some of these as you work problems. So they're typically donating one lone pair of electrons. So acceptor atoms are the transition metals themselves. And so the transition metals are acting as Lewis acids. And so then they would be accepting those lone pairs of electrons. So you can think about coordination complexes as Lewis acids and Lewis bases, or acceptor atoms and donor ligands or donor atoms. So here are some examples of transition metals that we're going to see. So it's that sort of D block of the periodic table that we'll become very familiar with in this unit. So then when you take your acceptor atom and your donor atom and you put them together, you get what is known as coordination complexes. So coordination complex is just the metal or the Lewis acids surrounded by the ligands, or the Lewis bases or the donor atoms. And here is an example of a coordination complex. We have metal, we have cobalt in the middle, and it's surrounded by a series of ligands, and these are NH3 ligands. And so then our cobalt in the center, our metal, is the Lewis acid, and it's going to be the acceptor atom. And the NH3 groups are our Lewis bases. They're donor atoms. You see it's written with those two electrons there, that they're sharing their electrons with the cobalt, forming this coordination complex. And in this scheme, we have these, the bonds that are just these straight lines are in the plane. The thick bonds coming out are coming out towards you, and the dashed lines going back are going back into the screen here.